All right, let's get this unit started. Let's start off with a little bit of a warm-up, all right? We're going to answer all of our exponents here and see what we can know. So it says fill in the blanks of the powers and squares for the following. So 1 squared, 1 times itself, that's just 1. 2 squared, that's 4. What squared gives us 9? 3 squared gives us 9. Okay. 4 squared, that's 16. What squared gives us 25? 5 squared gives us 25. 6 squared, that's 36. 7 squared, that's 49. 8 squared, that's 64. What squared gives us 81? 9. 9 squared gives us 81. 10 squared is 100. And what squared gives us 121? 11. 11 squared. And 12 squared is 144. Now, hopefully you have that kind of stuff built in at this point, and it's just kind of math memory, and you're just kind of spitting it off at this point. So let's look at another problem. Determine the value of c, x squared plus 6x plus c, that makes the expression x squared plus 6x plus c a perfect square trinomial. Remember what a perfect square trinomial is. A perfect square trinomial has the form a squared plus or minus 2ab plus b squared. Okay? So what that means is that c is equal to b squared. That's what we're looking at here. All right. So c is equal to b squared. How will that help us? I don't know. Well, guess we'll find out. Let's go through all of our values. All right. So we're looking at a squared. What does that mean? A is what? What's in front of the x squared? Well, a 1. So a is equal to 1. All right. And what is b? B is the term inside, where are we here? B is at the end, right? So we have our c down here. So what is b? C, all these letters are getting confusing if we look at this right here. C is actually equal to b squared. So what is b equal to? Take the square root of both sides, and we end up with b is equal to the square root of c. Okay. The same thing was over here as well, right? It was the exact same idea, except the square root of 1 is just 1. What else do we know? Well, we know that that middle term needs to be equal to whatever value sit in front of that x. So we know that 2ab is equal to 6. So now what we want to do is we want to substitute all the values we know in. We know 2. 2 is 2. We know a. A is just a 1. And we know b is root c. And that's all equal to 6. So we want to keep solving until we find a value for c. Well, 2 times 1 is just 2. Okay, so we'll rewrite it over here. 2 times root c is equal to 6. Let's get rid of that 2 by dividing both sides by 2. So we have root c is equal to 3. 6 divided by 2 is 3. Now I got to get rid of that square root. In order to get rid of that square root, I need to take the square of both sides. So c is going to be equal to 3 squared, or c is equal to 9. Well, that's all we needed. So now we have our nice little therefore statement. So therefore, a value of c is equal to 9 makes it a perfect square trinomial. Now, the whole point of this is that it's going to lend itself right into our lesson today. But let's start off with a little bit of a refresher. If you remember from the last lesson, sometimes we're going to start with a standard form, right? We might start with a standard form, which is y is equal to ax squared. Well, that is pretty terrible. Give me my eraser. There we go. Erase the whole thing. Doesn't want me to. So we have y is equal to ax squared plus bx plus c. That's our standard form. But sometimes we may need to get to factored form. So in order to get to factored form, what did we have to do to the standard form? We had to factor it. And that is why it's called factored form, which is y is equal to a times x minus r times x minus s. But you know what? Sometimes from the standard form, we may need to get to vertex form. Sometimes we need to get to vertex form, which is y is equal to a times x minus h all squared plus k. So sometimes we need to go in this direction. But how? Is there a way to get from standard form to vertex form? Because it certainly is a nice easy way, like just regular factoring. Or is there? Well, let's find out. Let's see what we can do here. So if we have a quadratic relations in the form of y is equal to a times x minus h squared plus k, which we call the vertex form, it can be rewritten as ax squared plus bx plus c standard form by simply expanding. So if you have vertex form and you just multiply it out, you get the standard form. And the same thing goes when you're in factored form. If you're in the factored form and you multiply it out, you're going to go back to standard form again. So both ways, you can get back to standard form by expanding. Right? I can go back to standard form by expanding. That sometimes might be useful, but we'll see. Okay? Oh, expanding. Let's not expanded. Expanding. Why don't you like me? Erase. There we go. Expanding. All right. So let's say that we have a quadratic relation in the standard form. We want to be able to rewrite it. We want to take it from standard form and take it into vertex form. We can do this by doing a process called completing the square. It's better if I can spell it right. Come on, computer. You can do this. Oh, look at that. You can actually see it. Give it a second. Everything is lagging. So basically what I'm saying here is that by doing a process called completing the square, we can convert it from standard form to vertex form. What does that actually mean? Completing the square means we're going to force it into a perfect square trinomial. And that's going to allow us to take it that extra step into vertex form. So we're going to force... Yeah, we're going to force a perfect square trinomial. Now that's interesting. I wonder how we can do that. Well, we just got to make sure that it gets to this format, and then we'll be able to apply the knowledge that we have. So completing the square. All right. Once in vertex form, once in the vertex, we can find the vertex. We can find the max. Or the minimum with that vertex information. I am going to rewrite that. I'm in too much of a hurry right now, and I'm making bad spelling mistakes here. If it ever wants to work. Come on. I might need to reboot my computer here. Oh, it caught up on its own. Whatever. Anyways, so how do we actually complete the square? Well, once you've done it once, it's nice and easy. But you have to do it once first to actually see what we're doing. So we're going to start with an equation, or sorry, not an equation. We're going to start with a relation in standard form. Easy enough. Y is equal to ax squared plus bx plus c. Here's an example on the right here. Y is equal to 2x squared plus 16 plus 3. Great. The next piece we're going to do is we're going to factor it. Okay? We're going to factor a, only a, from the first term. We're going to factor only a from the first term. Even if we could factor more than that, we're not going to. We're only going to factor a. Okay? So in this case, and it's from the first two terms, we're going to ignore that third term. We're going to leave it alone. So that means in this step, I have y is equal to our a, which is the 2. And inside of that set of brackets, I have x squared plus 16 divided by 2, that's 8x. And then we still have our plus 3. If I wanted to bring these terms back out of the brackets, I would have to multiply that 2 through again. And that would give me 2x squared plus 16x again. So we could put it back the way we had it just by multiplying the 2 to the terms that we need to multiply to. Okay, so now the next step. This is the kicker to the whole thing. This looks more complicated than it actually is. What we're going to do is inside the brackets are there for a reason. So inside the brackets, we're going to both add and subtract a very special value. That value is going to be half of our b term squared. Half of our b term squared. So half of 8 is 4. And then we're going to square that, and that's 16. So half of our b term, b over 2, squared. So y is equal to, we leave the 2 alone, we leave the x squared alone, we leave the 8x alone, and now we're going to add and subtract half of the b term squared. Half of 8 is 4, squared is 16. We're going to add 16, and we're going to subtract 16. You're like, how can you just do that? Well, mathematically, if I both add and subtract the same number, I've essentially done nothing. So I haven't changed the equation at all. You should be thinking to yourself, I still don't see how you've created a perfect square trinomial yet. Well, that's because we got 4 terms in here. We got to get rid of one. The next step is where we're going to bring it down to 3 terms inside. So what we're going to do is we're going to now expand the subtracted term. We're going to get rid of we're going to bring the subtracted term back out to the outside. And like I said a second ago, anytime I want to bring something outside of the brackets, I simply have to multiply it by the a term, and then it'll still be valid. So if I want to bring that negative 16 out, it's going to be negative 16 times 2. So that's negative 32. So expand the subtracted term outside of the bracket by multiplying it by a. Okay, so that means we're going to bring it out this direction, and it's going to be negative 16 times a. Well, a is equal to 2, which gives us negative 32. That's what we're going to do. We're going to bring that negative 16 out. So we end up with y is equal to 2 times, inside the brackets, the only thing we're left is x squared plus 8x plus 16. Close the bracket now. And on the outside, we have that plus 3 and then minus 32. Final step. Oh, look what we just created. This is a perfect square trinomial. And it will always be a perfect square trinomial because we forced it into that situation by adding and subtracting half the b term squared. We set up the 2ab by doing this. Okay, so if this is a perfect square trinomial, that means the 2 gets left alone, but this becomes the square root of the first term, which is x, the sine of the middle term, plus, and then the square root of the last term, which is 4, and the whole thing is squared. And then on the outside, we have plus 3 minus 32, so that's minus 29. And that's it. Look, we have vertex form. A times x minus h squared plus k. Awesome. And it's always the same steps. Factor out the a, then you factor out the a from the first 2 terms. Then inside, add and subtract half the b term, so half the 8 squared. So half of 8 is 4, squared is 16. And then you're going to bring the 4th value out of the brackets by multiplying it by a. And then finally, you're just going to factor the perfect square trinomial on the inside. And that's what we call completing the square. This gets used in a lot of different places in future areas for mathematics because sometimes we just need something to get into this vertex form for whatever reason. Usually it's to solve some specific problem because oftentimes when we have a parabola, we need to know where that vertex is, and that's super important. And we can't just pull that information out of a standard form quadratic relation unless we do a table of values, and that's not something we want to do. Oh, I forgot to fill in this blank here. Down here, so we factor the perfect square trinomial. Okay, let's go show some quick examples of what we're talking about here. Dun, 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 dun. Alrighty, so it says, find the vertex and the maximum or minimum value of the following parabolas. So I want to remind you, the vertex is the maximum or minimum of the parabola, depending on whether it opens up or down. All it's asking us for is, for these two values here, what is y at the vertex? That's all the maximum minimum is actually asking you. All right, so we're going to follow the process. In this case, we're going to take the first two terms and we're going to factor out a. There is no a this time. Awesome. That makes life easy. So we just have our two terms, x squared minus 4x. That's one term now. And we're going to have minus 10 sitting on the outside. Now what we have to do, we now have to add and subtract half of the second term squared. So half of 4 squared is 4. Half of squared is 2. Square that is 4. Sorry, half of 4 is 2. Square that, we get 4. So x squared minus 4x plus 4 minus 4. And then the minus 10 is still sitting there on the outside. Next step is we got to get rid of the minus 4. We bring it out to the outside, but we have to multiply it by a. A just happens to be 1 right now. So inside we still have x squared minus 4x plus 4. Now on the outside we have our minus 10, and minus 4 times 1 is still minus 4. Now we're going to factor this new perfect square trinomial, which is going to be the square root of the first term, the sine of the second term, and the square root of the last term. And that whole thing is squared. And now minus 10 minus 4, that's minus 14. So there is our vertex. Our vertex is located at 2, negative 14, HK. And our min value, how do I know it's a min? Because an a value of 1, which means it opens up. So it's a min value of negative 14. Now we rinse and repeat. We got 5 more of these, and that's basically all we're doing this lesson. So hopefully you can pause the video and try it on your own. First thing, we're going to factor out the a term from the first two values. We're going to factor out the a from the first two terms. Those guys right there. So what's our a? Our a is negative 4. So the first term becomes just x squared. Now negative 32 divided by negative 4 gives us positive 8x. And then we have our plus 9 sitting all there on its own. All right, let's keep going. So we have negative 4. We leave that alone. Inside we have x squared plus 8x. And now I want to take half of the second term, that's 4, and then square that. That's 16. So we're going to add and subtract 16. 16 minus 16. And the plus 9 gets left alone. Now we got to bring that negative 16 outside. So we still have our negative 4, x squared plus 8x plus 16. But now we're bringing that minus 16 out. What's minus 16 times negative 4? That's positive 64. So plus 9 plus 64. And now we can factor our perfect square trinomial. And now remember, that is the square root of the first term, the sine of the second term, and the square root of the last term. And that whole thing is squared. Now on the outside, we have 9 plus 64, which is just 73. So where's our vertex? Our vertex is located at HK. H is negative 4, and K is 73. All right. And do we have a max or a minimum? A is a negative value this time. A is a negative, so that means it opens down. So that means we have a max value. And our max value is a 73. Great. Moving on to the next one. Same old stuff. So I know every one of you right now is looking at that and saying, oh, I can factor out a greatest common factor from all 3 of those. I can get rid of that 3. But we don't want to do that because our goal is not to factor this. Our goal is to put it into vertex form by completing the square. So we're just going to be focusing on those first 2 terms. So y is equal to, we're going to factor out the 3 from the first 2 terms. So 3, and then internally we have x squared, and minus 48. So 48 divided by 3 is 16. So minus 16x. And then we have our plus 12 on the outside. Eventually, you're going to get good enough that you can combine this first step and the next step all in one go. But for the beginning, take your time and make sure it's right. So we have 3 times x squared minus 16x. Now we need to add and subtract. What are we adding and subtracting? Half of the second term. So half of 16 is 8. And then square it. That's 64. So plus 64 and minus 64. Okay. And then we have our plus 12 at the end. Now, so what I'm saying is eventually you'll get good enough that you know what you're doing here, that you'll be able to combine both these steps and just go directly to the second step. But until you get to that point, take your time and make sure your math is correct. Okay. So now we got to take out that negative 64 from inside, the minus 64 from inside, which means we're going to have to multiply it by 3 to do that. So 3 gets left alone here. We have x squared minus 16x plus 64. And then on the outside, we have our plus 12. And now minus 64 times 3, that's going to give you minus 192. Okay. Now in this final step here, we are going to say 3, and now we're going to factor our perfect square trinomial. So the square root of the first term, x. The sine of the second term, subtract. And the square root of the third term, which is 8, all squared. And now we finish the math over here, which would give us minus 180. Now some of you will go directly from step 2 here and go right into step 4. Also okay, if you get the math right. I can't give you part marks if you make a mistake in that process. So be careful, be mindful. So what's our vertex located at? So HK, H is an 8, positive 8, and K is negative 180. That is quite the vertex. Now, is it a max or a min? Well, if we look, we can see that our A value is a positive number, which means it opens up, which means it's a min value. It's a min value of what? Negative 180. There we go. Let's go to the next one. Yep, we're going to do all of these. If you feel you're comfortable, you can kind of mosey on and keep moving. But it's up to you. I would pause the video and try them on your own just to verify that before you do something silly and just ignore the work. Okay. So now we have everybody's favorite, which is a fraction. It is what it is. Okay. So first thing, we're going to take those first two terms and we're going to factor out our A. What's our A this time? It's a third. So y is equal to 1/3. Now, if I do 1/3 divided by 1/3, that's still just a 1, so we end up with x squared. Okay. Now, what's 4 divided by a third? Now, hopefully some of you can do this in your head, but you don't have to. 4 divided by 1/3. I'm dividing by a fraction. So that's the same thing as saying 4 times the reciprocal, 3 over 1. Oh, that just gives me 12. Nice. So we have minus 12x. Close the bracket, add on our 3. Okay, now we go to the next step. Y is equal to 1/3, and then x squared minus 12x. Now we need to add and subtract. Half of 12 is 6. 6 squared is 36, plus 36 minus 36. And then on the outside, we get our plus 3. Okay, keep going. Y is equal to 1/3. Now we need to take that negative 36 out. So inside we have x squared minus 12x plus 36. And on the outside, we have minus 36 times a third. So what's a third of 36? It's 12. So we have plus 3 minus 12. And now we do our perfect square trinomial factoring. That's square root of the first term, sine of the second term, square root of the last term, all squared. And then 3 minus 12 is negative 9. Alrighty, where's our vertex? Our vertex is located at HK. H is a 6. And K is a negative 9. Awesome. And now do we have a max or a minimum? Well, 1/3 is definitely a positive number, so it's opening up, which means we have a minimum value. And that minimum value is negative 9. Okay. Moving on. So we have y is equal to 9x squared minus 12x plus 4. Same idea that we had before. So we're going to factor out from the first two terms. Y is equal to 9. And now inside we have x squared. And 12 divided by 9, well, that's not a very great number. Maybe we can shrink that down. So we have 12 divided by 9. Well, we can reduce that to 4 over 3. So 4/3. Okay. So minus 4/3 x. Close our brackets. And we have plus 4. Now we got to do a little bit more work. We have to add and subtract our middle term stuff in here. So let's do this. Y is equal to 9 x squared minus 4/3 x. Now, we need to find half of 4/3. How do we get half of 4/3? What does that mean? It's 4/3 divided by 2. What does that mean? Well, if we think about it, that is the same thing as 2 over 1. We're dividing by a fraction here. So that's the same thing as 4/3 times the reciprocal, 1 over 2. So that's 4/6. But we can reduce that to just 2/3. Okay. So we have 2/3. That's half of our 4/3. But we need to add and subtract that number squared. 2/3 squared. Well, that's the square of the top term and the square of the bottom term. So that's 4 over 9. There we go. So we're adding 4 over 9. And we're subtracting 4 over 9. And the plus 4 is still sitting here on the side. Let's keep going. So we have y is equal to 9. Inside, we're going to have x squared minus 4/3 x plus 4/9. And on the outside, we got to bring that minus 4/9 outside. But in order to do that, we have to multiply it by a. So multiplying it by 9. Well, that's the same thing as 9 over 1. So the 9's cancel out. So we just end up with negative 4. Nice. So we have our plus 4 minus 4. So now we're looking at this. 9. And we have a perfect square trinomial, believe it or not. So the square root of the first term, x, sine of the second term, square root of the third term, 2 over 3. And that whole thing is squared. And now we have plus 4 minus 4. Oh, that's just 0. We're done. That's the whole thing. So what's our vertex? Our vertex is located at h. Well, that's 2/3. And k. There is no k. So that's plus 0. That's 0. 0. 2/3 and 0. Do we have a max or a min? Our a value is positive, so we have a min. And its value is 0. That's the whole question. All right, one last one. So in this case, we have negative 1/2 x squared minus 4x. All right, so we still have two terms. We're going to still follow the same process. Y is equal to, we're going to factor out a, which is negative 1/2. Inside, we have x squared. And now we have 4 divided by a half. 4 divided by negative a half, really. That's the same thing as saying 4 times negative 2 over 1. So that's just going to give us negative 8. Good. So let's do that. So in this case, we're going to have minus 4x. Or sorry, 8x. I don't know why I said 4. Minus 8x. Okay. Now what? We don't have a k on the outside, so we just leave it alone. We're moving on. So inside we have, or the next piece, we have negative 1/2. We leave that alone. We have our x squared minus our 8x, and now we need to add and subtract. Half the second term, so half of 8 is 4. Now square that is 16. So we're going to add and subtract 16. We've been here before. Okay, and now we got to get rid of that fourth term. Y is negative 1/2. And inside we're going to have x squared minus 8x plus 16. Now we're going to take that negative 16 and multiply that negative 16 by a half. So that's negative 16 over negative 2. That just gives us a nice, reasonable, positive 8. And now we just need to do our perfect square trinomial factoring. Negative 1/2. And now square root of the first term, sine of the second term, square root of the last term, all squared, plus 8. There's our final relation. Now we just need to put everything together. So our vertex is 4 8, 4 from the negative 4 here, and 8 from the outside. And then finally, do we have a max or a min? Well, that's a negative number. So that means that we have a maximum. Whenever a is a negative number, we have a maximum because it's opening down. So the max value is 8. So this is what we call completing the square. And this is going to be, again, a super important aspect to solving a number of our problems going forward. That's it for now. Let's get on to the next one.